What's up everybody? Moving on to the next example. If y is equal to u squared minus in brackets u to the power 3 minus 2 to the power of 2 and u is equal to the square root of 7 minus x, find dy by dx at an x value of 3. So we have to find the derivative of y in terms of x. Now notice how we have to find the derivative of y in terms of x, but we're given y in terms of u and then u in terms of x. So we know to find the derivative of y in terms of x, we're going to have to apply the chain rule. And that's equal to the derivative of y in terms of u times the derivative of u in terms of x. This is the other notation for the chain rule. And because we're not given a full composite function in one piece, the functions are split up, we know we're going to have to use this notation for the chain rule, and it's going to make our lives a lot easier. I'll show you how. But notice another way we can do it is we can take this u, this expression for u, the square root of 7 minus x, and then plug it in for this u here. But then we're going to have a crazy expression for y, and then finding the derivative would take us a very long time. Though it's possible, it's going to take a lot longer. It's a lot easier to just use this notation here. So our first step, let's find the derivative of y in terms of u. So finding the derivative of this function that we're given here. So the first thing we do, we find the derivative of this expression, which is just 2u. And then the derivative of this whole expression, u to the power 3 minus 2 to the power of 2, notice how we're going to have to apply the chain rule because it's a function within another function. The inner function is this u to the power of 3 minus 2. The outer function is u squared. So taking the derivative of that outer function first, we bring the 2 down, subtract 1 from the exponent, keep that inner function the same. Then we have to multiply it by the derivative of that inner function, and the derivative of that inner function is 3u squared. So that whole first bracket here represents dy by du, and now let's find du by dx. So we have to find the derivative of this function here, the derivative of u in terms of x. So notice how we can rewrite the square root of 7 minus x as 7 minus x to the power of a half. And again, to find the derivative of that, we just apply the chain rule because it's a function within another function. The inner function is 7 minus x, the outer function is x to the power of a half. So we take the derivative of that outer function first, so we bring the 1/2 down. The inner function stays the same. We subtract 1 from the exponent, so 1/2 minus 1 gives us negative a half. And then the derivative of that inner function is negative 1. So this second square bracket here represents du by dx. Now, usually what happens is when we're finding the derivative of y in terms of x, the general derivative, you want everything to be in terms of x. So if we were doing that in this case, we would plug in that expression of u, which is in terms of x, the square root of 7 minus x, into all the u's here. And then our derivative would be all in terms of x. However, in this specific question, because we're finding the value of the derivative at a specific x value, we can plug in that x value in this bracket, but then for this bracket, we can just find what the u value is when the x value is equal to 3, and then plug in that u value into this bracket. So here's what I mean. So we know u is equal to the square root of 7 minus x. Well, when x is 3, u is just going to be the square root of 7 minus 3. 7 minus 3 is 4, square root of 4 is 2. It's technically plus or minus 2, but let's just assume it's positive 2 in this case. So u is equal to 2 when x is equal to 3. So we can take that u value of 2 and plug it in for all the u values in this bracket, and then we can take that x value of 3 and plug it into all the x values in this bracket, and we would get the value of that derivative at that x value of 3. So it's a lot easier doing it that way versus taking this expression u in terms of x, plugging it in to this big expression. You increase your chances of making a mistake. You'll get a crazy expression, then you could plug in that x value of 3 for everything. But again, it's a lot more work and you increase your chances of making a mistake. Easier to just find that u value when that x value is 3 and then just plug in that u value into that first bracket. So then when we do that, when we plug that u value of 2 into this first bracket, we would end up with 4 minus 144. which would end up giving us negative 140. And then when we plug in that x value of 3 into this bracket, we would get 1/2 times 1/2 here, because 7 minus 3 is 4, and then 4 to the power of negative 1/2 is 1/2 as well, times that negative 1. So negative 140 times negative 1 over 4 would give us positive 35. So that there is our final answer for the value of the derivative of y in terms of x at an x value of 3. So we applied the chain rule, but we applied it using this notation because the functions were split up. And then the important part, because we're not finding a general derivative or finding a specific derivative at an x value of 3, find what the u value is at that x value 3, plug in the u value into that first derivative dy by du, and then plug in that x value into dy by dx, and then simplify everything, and you get that final value of 35. Yo, what's up guys? Thanks for checking out my channel. Hopefully you got some value from the video you just watched. If you did get some value, big favor to ask you, please like this video and subscribe to the channel. Any questions, any recommendations on things you'd like to see, please leave it in the comments section. Also check out the description box below for links to material and content related to the video you just watched. Peace out.